Hello everyone, this is part 1 video on past year NEET questions from the chapter Kinetic Theory of Gases in Physics. We'll start with the question that has come in the NEET 2019 paper. Increase in temperature of a gas filled in a container would lead to, means we are actually keeping the gas inside the container. So the thing is what, so if you take a container and keep a gas inside, that means the volume of the container is basically fixed. Okay, and since we are keeping this enclosed, whatever the amount of the gas, right? So amount of the gas, either we can represent it in terms of mass or the number of moles. Amount of gas also is not going to be changing. What we are doing is we are basically increasing the temperature. So we have to conclude which of the 4 options will be the most possible outcome. So look at this, so here we will have to go through each of these options and check whether they are the suitable condition or not. So option A is what? Decrease in the intermolecular distance. Now some people will confuse this with the mean free path. So mean free path is different. Mean free path is what? That is the average distance between 2 successive collisions. Intermolecular distance means it is a very generic term. So if you look at the particles which are separated by some distance, that average value of the separation is what you take as the intermolecular distance. And intermolecular distance will depend upon what is the number of particles and what is the available volume. So intermolecular distance will depend upon what is the number of particles and the available volume. Here if you see, number of particles is not changing, available volume is also not changing, so intermolecular distance will not be changing. Okay, so option A is not the suitable one. Option B is what? It results in increase in mass. No, the amount of gas is fixed, right? There will be no increase or decrease in the mass. Option C is what? Increase in its kinetic energy. Remember, no, as per the kinetic gas theory, right? For any amount of gas, the kinetic energy will be directly proportional to the absolute value of the temperature. So kinetic energy will be depending upon the temperature. So if you increase the temperature, means kinetic energy also will be what? Increasing. So the correct answer for this is option C. Option D is saying decrease in its pressure. Now if you fix number of moles, fix volume, and increase the temperature. So look at the ideal gas equation. What is it? PV is equal to what? nRT. So from here, P is equal to what? nRT by V. So we can see N is fixed, R is anyway gas constant, it's a constant. Volume is also fixed, means pressure is directly proportional to what? Temperature. So if you increase temperature, means pressure will actually increase, pressure will not be decreasing. Okay, so the correct answer is what? Option C is the right answer for this question. We'll move on to the next question. This is coming in the 2018 paper. At what temperature will the RMS speed of oxygen molecules just sufficient for escaping from the Earth's atmosphere? So Earth's atmosphere, right? If any particle or whatever it is has to escape, means it should have a velocity or speed which is equal to what? The escape velocity. What is the escape velocity from the Earth's atmosphere or the surface of the Earth? It is nearly 11.2 km per second or 11,200 meter per second. So the RMS speed of the oxygen molecules, right, should be equal to what? This is 11,200 meter per second. What is the RMS speed formula? Vrms, right, will be equal to what? Either root 3 RT by capital M. Here R is the gas constant per mole and capital M represents what? It represents the molar mass of the molecule. Otherwise we can also write the formula in terms of Boltzmann constant. What is it? Root 3 kT by small m. K is the Boltzmann constant, small m is mass of one molecule. So here probably we have to use this equation. Why? Because they are giving us what is the mass of oxygen molecule. One molecule mass they are giving small m. And also they are giving us the Boltzmann constant. So Boltzmann constant either you can represent by the symbol K or KB. Okay, because in some other chapters, right, we'll use K for what? Spring constant, even the thermal conductivity. So we use K quite often. So differentiate, we can even use K subscript B like that. Okay, so what is it? It's a straight equation based question. So escape velocity, we know approximately what is it? 11,200 meter per second. And what is the RMS speed formula? Root 3 kb into T by m. M is what? The mass of the oxygen molecule. So here if you look at it, right, everything is given except the temperature, because Boltzmann constant value is given, mass of the oxygen molecule is given. So we are looking at what is the temperature where the RMS speed is equal to escape. Only then the oxygen will be able to escape. So this is a reason, in fact, why certain hot planets, because you can see as temperature is increasing means what? The RMS speed also will be increasing. So certain hot planets, right, they would not be able to enclose air around them, because the RMS speed will be more than the escape velocity, means what? Whatever the gas that is there in the atmosphere will simply escape out of it. Okay, so that is the reason why we will not have the atmosphere in case of certain hot planets. So we look at it, what is the temperature required? So we have to simply equate escape speed or escape velocity is equal to what? Root 3 times kb into T by the mass of the oxygen molecule. So just substitute 11,200 on the left hand side is equal to what? Root of 3 into kb is what? 1.38 into 10 power minus 23 joule per Kelvin into temperature. So this temperature is going to be coming in the units of Kelvin, divided by what is the mass of the oxygen molecule. Everything here is in the SI system. It is what? 2.76 into 10 power minus 26 kgs. So everything is in the SI system. So temperature will be coming in what? Kelvin scale. So if you square on both sides, what we'll get? 11,200 the square is equal to what? 3 into 1.38 into 10 power minus 23 into capital T divided by 2.76 into 10 power minus 26. So we'll take everything to the left side. What we'll have? 11,200 square into 2.76 into 10 power minus 26 divided by 3 into 1.38 into 10 power minus 23. That is going to give us the temperature on the Kelvin scale. If we simplify it, right, we'll get the answer as 8.36 into 10 power 4 Kelvin. We can see this is like what? 83,600 Kelvin. Okay, so this will tell us that if the temperature is more than this, in fact in some hot planets cases, right, we may have the temperature even going up to some lakhs of degrees Celsius or Kelvin. So in that, what do we see? Those planets will not be having the atmosphere. Why? Because the gas would have simply escaped. The correct answer for this is option B. It's a straightforward question. The only thing is it will involve some numerical simplification in the last step. Okay, so we'll move on to the next question. This is the question that has come in the 2017. A gas mixture consists of 2 moles of O2 and 4 moles of argon at temperature T. Neglecting the vibrational modes, the total internal energy of the system is. So neglecting the vibrational modes, we have to tell what is the total internal energy of the system. So here this is a question based on the relation of internal energy with the degrees of freedom. So what is O2? It is a diatomic. So diatomic, right, will be having 2 rotational plus 3 translational, because diatomic, when we look at the rotational with respect to the axis where both the atoms are present or both the particles are present, with respect to this axis we will not consider the rotational degree of freedom. That's why we'll have 2 rotation and then 3 translation. Total the F value will be equal to what? 5. So here we are not considering the vibrational. Argon, which is a monoatomic, right, will have only 3 translational. So the degrees of freedom F will be equal to what? 3 for the argon. And for any gas, the total internal energy will be equal to what? N into F by 2 into R into T. So N is the number of moles and F by 2, F is what? The degrees of freedom. R is the gas constant, T is the temperature. That is the expression for the internal energy of the particular gas. So here what we need to keep in mind is the degrees of freedom for the oxygen and for the argon. Oxygen is diatomic, argon is what? Monoatomic. That is the reason why for oxygen F is equal to 5, for argon F will be equal to what? 3. So look at it. So for the oxygen, right, N1 into F1 by 2 into RT. So here oxygen, what is the number of moles? 2 moles, right? So N1 is what? 2. F is what? 5, right? Oxygen is diatomic. So 2 is cancelled. What is it? 5 RT. What about the argon case? Number of moles here is N2 into F by 2 RT. So here F is what? 3, right? Number of moles is 4. So 4 moles of argon is there. So 2 ones are 2 twos are. So totally what is it? 6 RT. They're asking what is the total energy of the system, right? So total energy means what? Oxygen energy plus argon energy. What is it? 5 RT plus 6 RT. How much it is going to be? It will be 11 RT. The correct answer is option C. We'll go to a question that has come in NEET paper 2 of 2016. A given sample of an ideal gas occupies a volume V at a pressure P and absolute temperature T. Absolute temperature means what? Temperature on the Kelvin scale. The mass of each molecule of the gas is small m. Here small m represents what? Mass of each molecule of the gas. Which of the following gives the density of the gas? So which of the following will be giving the expression for the density of the gas? Probably some of us will remember the formula for the density itself. But even otherwise, right, look at it. We have this gas equation. PV is equal to nRT. PV is equal to this N will be what? Mass of the gas by the molar mass into R into T. Okay, so here if you bring the volume to the right side, so what we'll have? P is equal to mass of the gas divided by volume into, we'll have molar mass in the denominator, R into T will be in the numerator. Okay, so what is mass of the gas by volume? It is the density. So what we'll have is P is equal to what? Density into RT by capital M. Capital M will be what? Molar mass of the gas. Okay, so from here what we can say, we are looking for density means what is the density? P into capital M by R into T. This is the density. So here what is capital M? Molar mass of the gas. R is what? The universal gas constant, which is also called as gas constant per mole. But if you take a look at these options, right, they are talking about not R but K. K is what? Boltzmann constant, which is called as what? Gas constant per molecule. So here if you look at the molar mass, right, what is molar mass? Small m, which is mass of each molecule into Avogadro number. That is the molar mass, because molar mass means what? Mass of 1 mole of these particles, right? Similarly, R will be equal to what? Boltzmann constant into Avogadro number. In fact, Boltzmann constant will be equal to what? R by Avogadro number. So K into Avogadro number is what? R. So we'll substitute. In place of R, what we are substituting? K into Avogadro number into T will be there. So we can see Avogadro number is cancelled. What we'll get? P into small m by K into T. That is what is the density. So this is the formula in terms of what? Mass of each molecule small m and Boltzmann constant K. The correct answer for this is option B. We'll move on to the question that has come in NEET paper 1 of 2016. This is again question based on the gas velocities. The molecules of a given mass of a gas have RMS velocity of 200 meter per second at 27 degrees Celsius and 1 into 10 power 5 Newton per meter square pressure. So at the initial condition, right, what is the initial condition? What is the temperature? 27 means in terms of Kelvin, right, what is it? 27 plus 273 means 300 Kelvin. Pressure is what? 1 into 10 power 5 pascals. Newton per meter square means pascal. Okay, so at this what is the RMS speed? 200 meter per second. Now when the temperature of the gas and the pressure are 127, and so in the second state, what is the temperature? 127. 127 means what? 127 plus 273, that will be 400 Kelvin. That is the temperature. And what is the pressure? Pressure is what? 0.05 into 10 power 5 pascals. So they're asking what is the RMS speed of the gas over here. Okay, see, For any gas, right, RMS speed can be either expressed in terms of temperature. What is it? Root 3 RT by capital M. Or we can also have the expression in terms of the pressure and density, root 3P by D. P is the pressure and D is the density. So here they have given us both in the case 1 or the initial state as well as the second case. They have given the temperature and pressure, but both of them will not come in the same formula. So either we use the temperature based relation or the pressure. But if you want to use the pressure relation, right, there is also the term of density about which we are not sure. Which means what? We would have to go with the formula where we know, because it is a same gas, right? Molar mass will be same in both the cases. R is anyway gas constant. So the only changing parameter will be what? Temperature. So we'll choose the relation for the RMS speed or RMS velocity, which is in terms of just temperature. So RMS speed formula can be given both in terms of temperature as well as pressure, but we'll go with what? The temperature relation. So initially, what is it? RMS speed, which is 200 meter per second. That is equal to what? Root 3 into R into, what is the temperature here? 300 by molar mass. Keep it as equation 1. Equation 2, second case, RMS speed will be equal to what? Root 3 into R into temperature, there is 400 by capital M, because it is the same gas. Now what we are going to do? We just have to take a ratio of them and eliminate. So here capital M, molar mass of the gas, is the unknown one, right? Unknown parameter. We can just eliminate it by taking a ratio. Now it is just simplification. So we got the two equations and we just have to eliminate the molar mass to get the unknown. Unknown here is what? The RMS speed. So get it? If you do equation 2 divided by equation 1, left hand side is what? V RMS by 200 meter per second is equal to, right hand side is what? Root of 3R into 400 by capital M divided by root of 3R into 300 by capital M. Okay, so we are doing equation 2 divided by equation 1. So root will not be cancelled. So some people will make that blunt mistake of cancelling the root also. Root will not be cancelled. Numerator we have root 3R, that will cancel with root 3R in the denominator. Here root M also will be cancelled. And we can even cancel this hundreds. So what we have is V RMS by 200 meter per second will be equal to what? Root of 4 by 3. So what is this? Root 4 means it will come out as what? 2. So 2 by root 3. So finally what we'll have? V RMS will be equal to, we will take the 200 to the other side. It will be what? 200 meter per second into 2 by 3, that will be equal to what? Not 2 by 3, 2 by root 3. So 400 divided by root 3 meter per second. So denominator we have a root 3. Okay. So the answer is what? 400 divided by root 3 meter per second. So that will be the RMS speed of that particular gas at the second condition. What is it? 127 degrees Celsius. We'll move on to the next question. Two vessels separately contain two ideal gases A and B at the same temperature, the pressure of A being twice that of B. The pressure of A is what? Twice that of B. Under such conditions, the density of A is found to be 1.5 times the density of B. The ratio of molecular weight of A to the molecular weight of B. So here we have to look at the density formula. Remember, what is the density formula? Density is equal to what? P into capital M by RT. So from here what we can have? The formula for the molecular weight is equal to what? dRT by P. D is the density, R is the gas constant, T is the temperature, and P is the pressure. So if you look at it, right, so we'll have gas A and gas B separately. So what are the relations given to us? Two vessels separately contain two ideal gases A and B at the same temperature. Means here also temperature is what? T. Here also temperature is T. Okay. The pressure of A being twice that of B means here if you say the pressure of B, right, let's say pressure of B, we are saying it as what? PB. Then pressure of A will be what? It will be 2 times the pressure of B. It will be 2 times, and the density of A is found to be 1.5 times the density of B, means density of B is say dB, density of A is what will be 1.5 times dB. So using this data we have to find what is the ratio of the molecular weights of A and B, means we have to find, what do you need to find, MA by MB. So what is MA by MB? Numerator is what, dA into R into temperature by PA, because in both the case temperature is same, divide by denominator is what, molecular weight of B means dB into R into T by PB. So R into T will be cancelled. So what is it, dA by dB into the PB will go to the numerator, PB by PA. What is dA by dB? So from here, right, dA we can write as what, 1.5 dB. Yeah. So look at this, I'm writing it over here. MA by MB is what, dA is 1.5 times dB, divide by dB, that will cancel, into PB divide by PA. PA is what, 2 times of PB. So what is it, 1.5 by 2. 1.5 by 2 means what, 1.5 itself is 3 by 2. So what is it, 3 by 4. So that is the ratio of the molecular weight of A to the molecular weight of B. So we are able to solve this question just by using the density formula. Okay, so whatever the derived formulas from the ideal gas equation, right, we should be keeping on top of our mind, so that these kind of questions when they come we will be able to easily get those marks. So this is a question that has come in the NEET 2013. In the given VT diagram, so they are giving us what, volume versus temperature diagram. What is the relation between the pressures P1 and P2? If you look at the line that is representing the pressure P1 and the line that is representing the pressure P2. So what are these? These are basically what, constant pressure. So this is also what, a constant pressure. So if you are drawing the graph of any process on the VT diagram, a straight line passing through origin will mean what, it will be meaning that it is a constant pressure process. Okay, so if you look at it, right, from the ideal gas equation, what do we have, PV is equal to nRT. So from here, here what is the y coordinate V, right? So what we'll have, V is equal to nRT by P. So in a way, if you look at it, this is like what, if the isobaric process means pressure is constant, means what, the entire multiplier nR by P. So here the nR by P is the multiplier, right, multiplied to temperature. This is the constant, no. So what we have is volume directly proportional to temperature. So this is what is the isobaric. So the VT graph, what do we see, it will be a straight line passing through the origin. Now the thing is here, we have to comment on what is the relation between P1 and P2. So if you talk about straight line passing through origin, right, this is like what, equation y is equal to mx. M will be what, the slope. M will be the slope. Slope here is given by what, tan theta for any straight line. For the first one, tan theta 1, second one tan theta 2. So here what we see is tan theta 2 is more than tan theta 1, means what, m2 is more than m1. So here if you observe it, right, m is what, m will be, compare this, m will be what, V is equal to nR by P into T. Compare both of them, m is what, nR by P, means the slope is inversely proportional to what, pressure. Means when the slope is higher means what, in that particular place the pressure will be less. So which means in the case of second one, the theta 2, slope is higher than the first, m2 is more than m1, means what, P2 will be less than P1. So wherever the relation is what, inverse, slope is inversely proportional to the pressure, right. So wherever the slope is more, in this case theta 2, you see that's a larger angle, right, tan theta will be in the first quadrant, 0 to 90, tan theta will be what, increasing with the angle, tan theta will be increasing with theta, right. So the second line is having a higher slope, means what, in that particular case the pressure is going to be less, means what, P2 should be less than P1. So correct answer is what, option A. Next we have a straightforward formula question based on the mean free path. So as per the kinetic gas theory, the gas molecules will be in continuous motion. They will keep colliding with the other molecules of the gas as well as with the walls of the container. So if you look at what is the average distance between two successive collisions, that is what we call as the mean free path. And here they are asking us what? The mean free path of molecules of a gas having a radius r is inversely proportional to, means we have to tell it is inversely proportional to either r cube or r square or r or root r. So if you look at the mean free path, right, lambda will be equal to 1 by root 2 n pi d square. So here n will represent the number density of the molecules, means number of molecules in given unit volume. D represents what? The diameter of the molecule. But what is diameter? 2r, right? Diameter is basically what? 2r, which means what? We'll have lambda is equal to what? 1 by, so in place of d we will put 2r the whole square. So it will be equal to what? 4r square. So lambda will be what? 1 by 4 root 2 n into pi into r square. So clearly what we see that the lambda is proportional to 1 by r square. We can say lambda is inversely proportional to what? R square. The correct answer is what? Option B. In fact, in 2020 NEET paper also we got question based on the same formula. In fact, they have straight away just asked the formula itself. They have asked formula for what is the mean free path. Okay, so these kind of questions we have to be carefully looking at, because these are like easy pickings provided you know the formula. If you are not able to remember the formula, means that's it, we will lose those marks. Okay, next we'll go to a question that has come in Karnataka paper 2013. In a vessel, the gas is at pressure P. If the mass of all the molecules is halved and their speed is doubled, so we are keeping the gas basically in a vessel, means what? Whatever the volume is basically fixed. Okay, if we are making the mass of the molecules half and their speeds are basically doubled, we are making the mass as what? Half and doubling the speed, then the resultant pressure will be how much? Means we have to find what is the final pressure. So for this, we'll use the kinetic gas theory equation, right? What is it? PV is equal to 1 by 3 mn V RMS the square. Otherwise, we are looking for specifically P, means P is equal to what? 1 by 3 mn by V into V RMS the square. So here what is it? M represents mass of each molecule, N is the total number of molecules in the container, V is the volume, and V RMS represents what? The RMS speed. So here initial case, right? What is the pressure P? Let's say the mass of the molecule is M. RMS speed is what? V RMS. Number of molecules is N. Volume is anyway fixed. Let us take it as what? V. Second case or the final case, right? What are we doing? We are changing the mass of the molecules. What are we saying? The mass of all the molecules is half, means mass is here what? M by 2. And the speed is doubled, means 2 times VRMS. So original speed is VRMS, means it is now what? 2 times. And the volume is fixed, number of the particles is fixed. Here we have to find what is the pressure P dash. Here we have to find what is the pressure P dash. Look at it. What is the pressure P dash value? 1 by 3 mass of the molecule, which is what? M by 2 into number of molecules is not changing as it is, divided by volume is also not changing. RMS velocity is square. RMS velocity is now what? 2 times. So if you look at it, right, what is it in the final case? So we are just going to get the expression that will relate to the original case. So P dash, the pressure in the second case, right, or the final case will be equal to what? Just look at it. What is it? 1 by 3. You will take this half to the front. Okay, so mn by V. This is what? 2 into VRMS the square, means what? 4 times VRMS the square. So bring the 4 also forward. What you'll have? 4 by 2, which is of course 2. So 2 into, remaining thing is as it is, right? 1 by 3 mn divided by capital V into VRMS the square. This is what? Our original pressure, initial pressure, means what? The P dash is equal to what? 2 times of the original pressure. So answer is what? Option A, which is 2 times of the P. So this question we are able to solve just by using what? The kinetic gas theory equation. PV is equal to 1 by 3 m into n into Vrms the square. So this is about the part 1 video, and we'll see in the part